Morning, students. I hope you all are fine. Today we are starting exercise number 1.6, and in the question number 1 they've given you set of equations, right? In the first questions, it's question number 1 and its first part, in which they have given you a set of matrix equations, sorry, and they have asked you to solve them by matrix invariant method. So let's see how do we solve these equations by using matrices. Firstly, let's write them in the form of matrices. Here you will get three matrices. Okay, the first one, let's write here A matrix, will be equals to all the entries you have on this side of the equation, right? And we will write them in the same order as they are. As the first one is 2, then we have minus 2, next one is 3, then we have plus 2 with y, so I'll write it here as it is. Now we get another matrix B, which is equals to the entries on the other side of the equation. So B will be equals to 4, 6, right? And then we have a matrix, third one, X matrix, which will be equals to all the variables that you have in the equations. As you can see in our equations, we have two variables, X and Y. So I'm going to write them here, X and Y. And basically, we're going to find the value of this matrix X, which means we will find the value of small x, this variable, and this Y. Okay, so let's see how we do that. We have X is equals to A inverse B. To find X, we have this, we're going to use this expression, X is equals to A inverse B. And you can see, firstly, we need to find the inverse of A. So let's do that. We're going to find the inverse of A. And to find the inverse, as we have done previously, the formula for inverse is equals to adjoint of that matrix divided by determinant of that matrix, right? So let's write the adjoint, or let's first find the determinant of A. This is our matrix A, so I'm going to write it here, 3, 2. And we know that to find the determinant, we multiply the diagonal entries. So 2 will be multiplied by 2, right? 2 into 2 minus, again, now it's we're going to multiply these two. So here, as we there is negative with 2, so I'm going to write that as well, minus 2 into 3, and it will be equals to 4 minus 6, and that will be equals to 10. So whenever you have this kind of question, or you're just finding the inverse of a matrix, firstly we find the determinant, because if determinant is 0, then we won't proceed further, we won't solve that question further, right? Because we know that any number over 0, let's say I have 1 over 0, is equals to infinity, undefined, so we don't solve that question. But as in this case, our determinant is not equals to 0, so we will proceed further and we will find the inverse of our matrix. As we know that for inverse we need two things, the determinant of that matrix and adjoint of that matrix. So now let's find the adjoint of this matrix A. And we know that for adjoint, first we replace the place of first diagonal. As we know that this is our first diagonal here, 2 2, and both are same, so there won't be any change anyway, right? And for the second diagonal, we change their symbols, right? Here we have minus 2, it will become plus 2. 3 is already positive, so it will become minus 3, and that's all. This is the adjoint of A. Now we can find the inverse of A, because we have both of things. We have adjoint of A and determinant of A. So let's put the values. So A inverse will be equals to adjoint of A, which is 2 minus 3, 2, 2, divided by determinant of A, which is 10, right? So this is the value of A inverse. This matrix is divided by 10. It means that all of the entries are being divided by 10. Right, now let's multiply. Now let's find this matrix, this matrix X, which is equals to A inverse into B. And we know that X is equals to A inverse into B. So let's write here A inverse, which is equals to 2 minus 3 2 2. I can write it as 1 over 10 into this matrix, right? I have just written A inverse as 1 over 10 into this matrix. Now I have just substituted the value of A inverse here. So let's write the value of B as well, which is 4 6 4 6. So as you can see clearly that A inverse is being multiplied with B matrix. So we are going to multiply these two matrices. So let's do that. Firstly, we will multiply this first. We are going to multiply this row with this column, right? 2 2s are 4, or let's write it separately. 2 into 4, right? Plus 2 into 6. Okay, so what we did, we just, as we have here only one column, so we multiply this first row with this column, right? In the next step we will multiply the value of we will multiply this second row with this column. So let's do that. We have here minus 3 into 4, first entry by this first entry, minus 3 into 4 plus 2 into 6, right? So we get 1 over 10 into 4 2s are 8 plus 6 2s are 12, minus 3 into 4 is minus 12 plus 6 2s are 12. So on further simplifying it, we get 8 plus 12 is 20, minus 12 plus 12 will be 0. So now we are going to divide this matrix by this 10, because this 10 means that it is being, this matrix is being divided by 10. So let's divide each entry of this matrix by 10. 20 over 10. Second entry is 0, 0 over 10. Right, and on simplifying we will have 20 over 10 will be 2, and 0 over anything is 0, because 0 over any number is always 0. So basically we just found this matrix X, and we know that in X the first entry is small x is the value of variable small x, and the second is the value of small y. So we have found the values of x and y, because this is equals to, x is equals to x y. So from here I can write that x, small x is equals to 2 and small y is equals to 0. And that's all we have for today. Allah Hafiz.